Hey guys, this is Mr. Bennett. I just figured it would be a good idea to do some quick review over multiplying and dividing powers of 10. So we're going to do some quick review over what are powers of 10. So when I talk about powers of 10, we're talking about exponents mainly. So 10 to the first power would equal 10. 10 to the second power would just be 10, it'd just be 10 times 10, and we know that equals 100. And then we've gone up to 10 to the third power, or 10 to the power of 3, which we know is really just 10 times 10 times 10, which would be 1,000, okay? And a lot of y'all pointed out in class that we can look at the exponents as kind of like a hint. So if you look at 10 to the power of 1, well, 1 is the exponent, and then we have 1, 0 as a placeholder on our number in standard form. The same thing works with 10 to the second power. We have 2 as our exponent, and we can count our placeholders or our zeros, 1, 2. And the same thing with 10 to the third power. The exponent's 3, and we have 1, 2, 3 zeros as placeholders. Okay, so everything checks out. So if I look at this from a multiplication point of view, so if I have a problem, let's get new color over here. If I have this problem, 25 times 10 to the first power is really just saying 25 times 10, because I know that 10 to the first power is 10. So 25 times 10 to the first power would equal 250. But there's kind of a hint or a shortcut way that you could look at this too. And this is going to work for just about any multiplying or dividing by powers of 10 problem that you could come up with, okay? So if you look at this number 25, and I'll write it again in a different color. If you look at 25, we talked about in class how this number could kind of have like this invisible decimal point right there, and we didn't see it the first time we wrote 25, but you can see it now. So you could think of any number like that having an invisible decimal point after the ones place, okay? And so those numbers 2 and 5, or those digits 2 and 5, they're actually just jumping one place value. Let me draw some spaces right here. They're just jumping one place value place to the left, okay, because they're being multiplied by 10. So I'm really just moving that 2 over here, and that 5 is going to go where the 2 was before, and it's kind of hard to see. So I'm going to erase this right here, and I'm really just moving the digits over one place to the left because I'm multiplying by 10 each time. Okay, and so I can't obviously just leave an empty space right there, so that's why I go back in and fill in a placeholder, which is my 0. So the answer still is 250, okay? Now there's another way you could look at this problem. If I go back to my original color, okay, and I'm just going to go ahead and erase this. So I'm going to take the same problem, which was 25 times 10 to the first power. And if you think about this number 25, take the same number, different color. If you take that number 25 and you still have your invisible decimal point, well, it's not invisible anymore, but if you still have your invisible decimal point, you're just moving that decimal point over one place to the right. Okay, and so it's going to be right here now. That's the new place for our decimal point. And then you just go back and you fill in your 0 as your placeholder. And so you still get 250. So 25 times 10 to the first power is 250. And we're going to look at both of those strategies again, but with a few more examples. So I'm going to go back And let's try a new one. Okay, let's try this one. 2 and 57 hundredths, or 2.57 times 10 to the power of 2. And we're going to try to solve this one, okay? So I can look at my decimal, and I know that this number is multiplying by a power of 10, so I know that my answer will be bigger than what I started with. So let's go ahead and look. And I know that if I'm multiplying by 10 to the second power, or 10 to the power of 2, how many times am I going to move my decimal point to the right so that my number gets bigger? I'm going to move it 2 times over. Okay, so I'm going to move it 2 times over and draw out my new spot. And sometimes it helps to rewrite the number again so you're not getting confused. So in other words, we can just say that this new number now is 257. And you don't have to put that decimal point again at the end, but you can if you want to, if it helps, keeps things clear for you. So my answer is going to be 257. 2.57, or 2 and 57 hundredths times 10 to the second power equals 257. Okay, now I'm going to leave that one there, and we're going to look at a second example. So let's do this one. We're going to look at 349 thousandths, or you could say 0.349 times 10 to the second power. We're going to solve this one now, okay? Same thing, I'm going to look at my decimal point, which is in front of the 3 this time, and I'm going to move it to the right the number of times that's listed in my exponent. So my exponent's 2, so I'm going to go ahead and take 0.349 and multiply it by 10 to the second power. All I'm going to do is going to take that decimal point and move it 2 places to the right, because that was what my exponent was. And you just kind of ignore where the decimal point was the first time, because now this is your new answer. And it's going to be 34 and 9/10, or 34.9, because that's where that new decimal point is going to be. Okay, so that's one way that we can use powers of 10 in multiplication. Now, if I wanted to look at it from a division point of view, let's go ahead and erase these. Division is pretty much, I mean, it is the opposite of multiplication. I'm just taking my number and I'm making it smaller. When I divide a number, it's going to be smaller than what it started off as. Okay, so here's my new example. 4 divided by 10 to the first power. Okay, and that 4 is going to be getting smaller, so make sure you're thinking of that whenever you're solving these problems, just to double check and make sure things make sense so that you're not messing yourself up. Okay, so I'm going to go back to my invisible decimal point like I was talking about earlier, because it's just going to come after the ones place. And since I'm dividing by a power of 10, my number is going to be getting smaller, so my decimal point is going to be moving to the left. And it's, you guessed it, we're going to move it to one place to the left, okay? Because we're dividing by 10 to the power of 1. So I'm going to take my decimal point and move it one place to the left. And here's going to be my new decimal point. Sometimes it helps to cross out the old one so you're not getting confused. And so now I can show that my answer is 4/10, or 0.4, because we know there could be like an imaginary 0 right there. But 4/10 is going to be the answer. I'm going to show another example. If I had 8.5, or 8 5/10 divided by 10 to the power of 3 this time. 8.5 divided by 10 to the power of 3. And you can pause the video if you want to. That way you can check yourself if you wanted to go and solve this problem on a scratch sheet of paper somewhere, just to double check and make sure that you can do this now. So I'll give you a second to pause the video. Okay, and now I'm going to go ahead and solve this one. So I've got 8.5 divided by 10 to the third power, or 10 to the power of 3. And I don't have to imagine my decimal point right here because they've already got it for me. And if I'm dividing by 10 to the power of 3, I'm moving my decimal point to the left and making my numbers smaller, okay? So it always helps me to make these little, like, loop-de-loops because that keeps track of my places at the same time, okay? So I'm going to take my decimal point and move it 1, 2, 3 places to the left. And that's going to be my new little home for it. And cross out the old place. But we can't just leave these places empty. Okay, and in math we know that instead of having an empty place, we just go back in and we put a placeholder in place. So our placeholders are going to be zeros because they have no value. They're not going to change how much the number's worth. And I'm just going to go in and write my new answer now. Okay, so I'm going to go ahead and write my decimal point, my 2 zeros, and then 8 and 5. Okay, and that's actually 85 ten-thousandths, which we don't really get to in 5th grade. We're only going to go up to the thousandths, but this is just an example. Or you could just say 0.0085. So that's going to be my new answer. All right. I'm going to do one more example, and then I think that we will have reviewed this enough to where you should be able to do some work on your own. Okay. So let's go back. Our new number is going to be 286 divided by 10 to the power of 5, or 10 to the 5th power. Okay. And you can pause the video again if you want to. That way you can try this on your own and come back and check your answer with me. All right. But I'm going to go ahead and keep working. So 286 divided by 10 to the power of 5. I'm going to take my red right here. And we already know that we're going to put our decimal point right here after the 6 because that's where it would be if you could see it. Since I'm dividing, my number is getting smaller, so I'm going to take my decimal point and move it 5 places to the left because that's what my exponent is. So I'm just going to go ahead and show that now. 1, 2, 3, 4, 5, and put my new decimal point right there. And I know that I just go back in and fill in those empty spots with zeros because those are my placeholders. And then I can go ahead and put my new answer in. 0.00286. Okay, so that's my answer for that problem. And you're going to see some of those in some independent work on your own. I think this week you guys have an IXL assigned for these problems, so that's really the main reason why I wanted to review these with you. That way you could be like, oh yeah, I remember we did that in class. Or if you can't remember, well, here's your review. So you guys rock. Good luck with your homework and all of your other work that you have assigned. Y'all are doing a fantastic job this year. And please, please, please email me or ask me in class if you have any questions, okay?